Let's jump into our next presentation, Democratization of Industrial Automation by Etienne Lacroix. Etienne is the founder of Vention.io, a next generation digital manufacturing platform for machine design that allows engineers and manufacturing professionals to design, simulate, and order automation systems online. Please take it away, Etienne.
Thank you very much, Mike. Thanks for having me today. This is extremely kind of you and the team at Design Engineering.
Great, thank you.
Welcome, everybody. My name is Etienne Lacroix, and I'm the founder and CEO of Vention.io. Vention is an online manufacturing automation platform for all type of manufacturers. And today I will be talking to you about the democratization of industrial automation for discrete manufacture. To give you a sense and context, Vention is a high-growth startup that was founded 4 years ago with the mission of democratizing industrial automation for all type of manufacturers, high mix, low volume, higher volumes, and so on. And to enable to serve this growing market of a larger number of manufacturers that want to start their industrial automation journey, we decided to review the delivery model of industrial automation, providing online first self-serve platform for users to be able to design, automate, obviously purchase and deploy industrial automation technology by themselves. And over the coming presentation, I'll be talking to you about how we see the trend unfolding in that industry, but also the type of tools that are now becoming available for various manufacturing professionals to jumpstart their industrial automation journey. A quick overview of Vention. Vention was founded in the summer of 2016, so we just turned a little bit over 4 years here. We're roughly 115 employees based in Montreal and other Canadian province supporting Vention. We are a venture-backed business, Canadian-owned venture-backed business with roughly 60 million of capital and funding received so far. Since the early days of Vention, we have deployed around 4,000 equipment in 1,000 factories on all 5 continents now. And Vention being a platform in its most purest fashion, we have the chance to work with amazing partners, and roughly of which 40 are actively participating in the Vention platform, and I have a chance to talk more about them in the coming minutes or so. But at its core, Vention is a software startup that interestingly create a lot of values by providing hardware technology. Now, I'll start today's discussion by talking about what is changing in the world of industrial automation. And all of you here today must have seen or have experienced firsthand the world of industrial automation as we know it, right? We've seen car factories, consumer electronics factories being fully automated for several decades now, and that's a true reality. But if you look at the broader range of manufacturer out there, there is a significant amount of manufacturers that today cannot automate. And the reason for that is fairly simple, is because the price point of acquiring and deploying more traditional industrial automation technology is such that unless you're a high throughput factory, it's really, really hard to generate an interesting payback. And the higher mix you are, the shorter the payback period you will expect, right? Most of the clients we have, we work with would like to achieve below 1 year payback. And by running hundreds and hundreds of business case and ROI simulation with our client, we tend to see this break point around 20,000 units a year, where below that, with traditional industrial automation technology, is really, really hard to achieve that given payback for higher mix manufacturers. There's a reason why industrial automation technology are costly. First of all, the price point of the technology has been geared for high throughput production, but also just the sheer cost of integrating technologies from various manufacturers into a comprehensive system is also quite manual and required very, expert professional to support such task. And that lead to, if you take an average industrial automation project going around $100,000, for example, very often we will see with traditional approach, roughly 50% of that amount being dedicated to technology, hardware and software, and the other 50% typically being related to integration costs or manual engineering hours required to deploy fully functioning system. And for a lot of manufacturers out there, this is a prohibitive investment, and payback will just not be there. Interestingly, I started my career in the world of machine design. I was a very young engineer sitting behind a CATIA station back in the early 2000s, and this is the process that I used to go through several times a year as I was supporting machine design for some of my clients back then. And we were starting most project once the spec was fully established by going on various industrial distributor website to find all the components and the technology we might need. And all those components, even though of extremely high quality and very well suited, were all operating across different standards. So you were finding those components, finding the 3D model, bringing that into your 3D CAD software, and realizing that a lot of those components use different standard, whether it's connectivity standard, protocol communication standard, or just mechanical standard. So realize that you have to design several custom parts to unite those custom components as one. And from those custom parts, you have to issue 2D drawings, you have to generate a bill of material that you can eventually give to procurement to start the sourcing process for the hundreds of components that a custom automated equipment might command. It's only after all the vendors were fine, typically, folks that will meet both quality and cost, that manufacturing could start, and eventually the assembly and the commissioning would go on. And obviously navigating that process was very, very manual. Like, it's very rare that I've seen one of those projects taking less than 2 months, and on average, I would say they are more closer to 4 than 2. And obviously a lot of the cost is just related to the interface cost, right? Having human from moving data from one environment to the next. So what happened for us around 2014 is we realized there's a humongous cost saving and time saving opportunities by removing those interface. But if we were able to provide a digital environment where users can select, design, automate, purchase, and obviously deploy their equipment in the comfort of a web browser, you would save a lot of time and therefore money. And as a result, drive down significantly the cost required to deploy industrial automation, expanding the market from where it is today. Those are some of the initial trend that we had seen in the early days of Vention, but there's a couple I want to point out because those trends are not going away, and I would even imagine that the world we're in with the pandemic would actually accelerate some of those trends that were there back in 2016. One thing for certain, when I, back in the early 2000s, designing custom industrial equipment for automotive and electronic clients, the platform of those products used to last between, a car could last for probably 7 years. Today, it's now 3.5. Consumer electronic products could last for 2.5, 3 years. Today, we see some of our clients operating on a 12-month basis for their consumer electronics product. So when the time window you have to design and deploy equipment is getting shorter, the amount that you can spend up front is also getting much shorter because you have then less time to depreciate that equipment. Out of a 12-month life product, if we can deploy the manufacturing system in 2 weeks instead of 3 months, we just gave the client back 25% of his product revenue payback, and that's substantial. To me, this shift in shorter product lifecycle really is opening a new era for industrial automation where the technology has to be right size to the product lifecycle. That's one of those trends that isn't going away. Another trend that isn't going away is just the shift in expectation. We have a chance to work with engineers that are at the front row of delivering those systems in various factories, and a lot of them are my age, and in a lot of cases much younger. And it's funny, recently I even had a discussion with young engineers that didn't know what a purchase order was. And it brings that expectation that people want their B2B vendor to operate just like Amazon. Single click purchasing online, you get your delivery next day and you're ready to deploy. And that behavior that was learned on the consumer side of things is now trickling down slowly in the B2B side of things as well. And on the long-term shift in demand, on the demand side, there's one more that is very, very interesting, is as we continue to automate our factories, it's very important, I think, that we continue to figure out ways to upskill our labor. We're entering a world where the labor that used to operate the factory today has to become the labor that will create the factory tomorrow. And with the democratization of industrial automation that start to kick in with technology like cobot and significantly more simple vision system, and I would say technology like Vention, we can now see a world where we can empower those manufacturing professionals to upskill themselves and play a much more value added role in their respective factory. Now, I'm sure a lot of you remember the early 2000 and the early 2009 years, right after both economic crisis. And for those that were in the machine design space back then, typically the following year of a crisis are quite interesting and quite good for the industry. And there's a reason for that, and we call that the rehiring dilemma, right? Some of the factories that might have right-sized their workforce during the pandemic will be face the dilemma of either rehiring their workforce to their pre-pandemic level or automate some of their previous operation. And we tend to see that the decision taken by those companies is a mix or an hybrid approach. Obviously, workforce will be rehired, but also more a process will be automated. And we expect this to drive great adoption of industrial automation in the coming years. Now, what we also see on the supply side of things that are shifting, how the market is getting democratized is, we see hardware technology provider, folks that manufacture cobot, vision system, end-of-arm tooling, that today tend to depend on a much more complex go-to-market model with several handshake required between the integrators, the distributors, and the end users, wanted to have a much more direct approach to end users. And the need to be able to deploy their product in a much more simplistic fashion where the end user can directly understand them and deploy them is leading as well to a lot of technologies to democratize our industry. A lot of those trends, and there's more I could have covered, but a lot of those trends are not going away, right? And they're reshaping the demand, they're reshaping who's the final customer, and they're reshaping what type of factory are now embarking on industrial automation project. And for us, this change in user, we call that almost a new era for industrial automation. For us, was the calling for a new category of software. We call it MAP, or Manufacturing Automation Platform. It's a category of software. Vention is one of them. I think there's other emerging as well as we speak, but it's a category of software whose primary mission is to empower a manufacturing professional to self-deploy industrial automation technology. In the world of automation, the beautiful thing is now there's enough modular component that the need to design custom part is significantly reduced. And as soon as this is true, you can imagine a platform where its primary goal is to make sure that the system being designed or assembled out of those modular parts or out of those Lego parts, that the software itself will make sure that the overall system will function. And interestingly, you can now start to envision a world where a lot of those tasks of validating system functionality can now be done by a software and a curated component list, as opposed to be done by specialized engineers in controlled and so on. And with that, obviously you significantly reduce the barriers for adoption. So for us, this new category of software is called MAP, Manufacturing Automation Platform. It brings aspect of 3D CAD software, of PLC programming, of PLM software, of definition requirement management software, and it brings them into a single digital that is united from the beginning to the end. And simplicity is significantly augmented by the fact that all the components available within the map are compatible with one another. So if a system is designed with those components, the end user know from the get-go that the system will work. You know, the map for us was the missing layer, right? We see this the beginning of the plug and play automation era, and I think a company like Universal Robots and ATS have demonstrated that you can already modularize a lot of the building block to deploy industrial automation. There's this need of reskilling the workforce, upskilling the workforce, and providing them an environment where they can become successful at designing and creating those systems. So again, the workforce that used to operate the factory today becomes one that now design the factory in the future. But to enable all those modular components, this new workforce to be able to design the factory to come together, we were missing that software, that manufacturing automation layer, that map, where it brings it all together in the same environment. So for us, MAP has 4 phases. A design phase that is mostly online, entirely online, where users can work out of modular parts coming from all sorts of partners that specialize in robots arm, in end-of-arm tooling, in conveyance technology, in vision system, and they're integrated in a way that if they are available, they are compatible with one another. So they are integrated in a very curated fashion. And end users can design environment because a lot of the software simplify, the 3D design software simplify the design experience. There's also an automate phase, an automation phase where users can program their machine in a code-free environment, again, keeping the barriers to adoption low, right? They can program their machine or simulate their machine in a code-free environment, making sure that the cycle time achieved in the digital world will be the same achieved in the physical world. And if the machine, the logic worked in the cloud, it can obviously be brought back directly on the equipment to be ran right there. They can also order, right? So after they complete their design, they see price in real time, they see their assembly time in real time, their entire bill of material as they design with modular part. If they want to proceed and move ahead with ordering those equipment, they can. Again, in the same environment where there's no information to be passed over from one system to the next. And the beauty of that is when you start to integrate the design, the automate, and the order phase, the act of deploying becomes significantly simple. Now, all the components are designed to work with one another, so you need a single tool assembly. The software already knows your equipment, so it can automatically generate assembly instruction in almost an IKEA fashion. The simulation was already proven online, so it can be easily deployed on the physical equipment to greatly speed up the commissioning. So that's how we see MAP shaping up. And by removing all those software interface and human interface, we can see a client today navigating from design up to deploy as fast as 3 days. And obviously this is supported by 24-hour or next day shipping once a machine is ordered. To show you that all in action, I'll ask Anna just to display a little short video that will last roughly 30 seconds.
Build custom industrial machines in days. Design your machine in the simplest online CAD. Get inspired by our public designs, or build your own in minutes. Program and simulate your machine directly in your browser. Build a broad range of automated equipment, no matter the complexity. Upon completing your design, review your bill of materials, select shipping options, and order. Receive your part kit within days. Assemble your machine using a single tool from beginning to end. Simple, quick, and efficient. Design your machine today. Receive it tomorrow.
That will give you a sense of where, what is possible today with today's technology in terms of simplifying the act of designing automated equipment. I'm just trying to change a slide as we speak. There we go. If we put those time saving together, right, to go from the traditional 2-month process and bring that down to a few days, we had a chance to work with clients that compare cost of their more traditional approach with the cost of an integrated approach for their specific project. And what we typically see is a lot of the cost saving do materialize as part of the engineering work. Less time, designing 3D equipment. This is typically reduced from weeks to just a couple of hours. Obviously, no need to create 2D drawing when you work out of modular parts only. No need to pay for a CAD license. Significantly faster procurement cycle, as information does need to be converted from one system to the next. Everybody has access to the online design and can proceed with purchasing and given their proper rights. Significant time reduced as well at validating component compatibility and figuring out how to integrate them during the deployment cycle. So if you start to compound all those effects, you start to materialize around 40% saving on average, mostly coming from the engineering components. And typically what we see is the, within the use case that can be served by the Vention platform, the higher the complexity, the more saving that can be provided to the end user. So those are the example of equipment that were deployed by our client. It goes from dual arm range extenders for shock absorber assembly, palletizer for frozen food, metrology equipment on the top right, inspection jigs for car body panel, pick and place machine in the bottom middle for solar panel, manufacturing equipment with self-drilling, self-programming capabilities in the bottom left. So the range of complexity varies greatly from more simplistic automated equipment to more complex automated equipment. But again, they've been through a very similar process where the starting point was an online design followed by an online purchase and self-commissioning afterward. So now I'm going to go over some of the technology building block behind MAP in the next 5 minutes. So if I go back to this MAP workflow, the design, automate, order, and deploy, I think there's several components of technology that are required to make this workflow work as one and provide the time saving we've defined. One of them for us is the ability to define requirement online. Very often with this new class of user that are getting, just beginning their learning and understanding of the industrial automation world, we need to give them tools so they can express what they need in a way that will lead to success. We'll call that machine scope in our case, but it's basically a requirement definition where folks can define their current process, define the new process, scope how they're going to validate that the new machine will work, and obviously define their holistic sets of requirements. 3D design online that is very simplistic, and for us we call that machine builder. If I move to the automate phase, machine logic, which is again a code-free way to program and simulate automated equipment. Machine motion, which is a control technology, and Simon touched a little bit on the control cabinet. Machine motion is a way for us to prevent users from having to create custom control cabinet, but instead use a box that is already equipped with all the requirements, the safety system, the drive, power supply, control infrastructure, and can be rapidly deploy without having to create a custom cabinet. Apps or purpose-built apps, we call that machine apps. But for example, client that want to deploy a pick and place machine, pattern drilling, pick and place, path following, no one should code those applications from scratch. There should be pre-built apps that can be tailored to the client's use case, and some of them are available obviously now. My team is the portal where team can collaborate. You know, one thing that every company and every users and every single company has in common is a web browser, and my team is a way to bring everybody together. So this is an example of machine scope that you see here. The control F disappear again. But this is a quick example of how machine scopes works. This is an example of machine builder. Again, on the left side, you see this modular part libraries that users can pick and choose from. All those parts are compatible with one another. On the top right, you actually see price in real time as components are added or removed. You can even see the commissioning time you'll need to assemble that machine based on the part selected. In terms of simplifying 3D design, which is really the starting point of every single automated equipment, the ability to work with modular parts or those Lego parts enable us to do design automation tasks that will not be possible in a traditional CAD. So I'm just going to point to a few of them. One of them is, we call that the configurator or component configuration engine. If somebody picks a linear actuators, the tool will drive the user to a step-by-step guide to configure that component properly. If a user want to, similarly, a part kit assistant would be a feature where if you want to use a light curtain, for example, you want to, light curtain comes in pairs, there's a left side, there's a right side, will guide the users through selecting all the proper components that are individual parts of a given kit. Design checker, this is one of my personal favorite. Design checker is a procedural engine to make sure that the design will work in reality, that all the law of physics will be respected. To some extent, design checker is a spell check for machine design. And as we build more and more automation, that type of technology become more and more sophisticated. And there's other, instructor at the middle bottom is an interesting one where users can learn how to design industrial automation equipment with a step-by-step guide as they actually design their intended equipment, which make the act of learning very easy and accessible to a broad class of user. Machine logic, again, this code-free environment that replaced the more traditional PLC programming interface where users can still create fairly complex program with loops and variables and conditional logics and create applications that are hardware agnostic, that, if it's a timing belt or a ball screw actuators, the software remains valid and is hardware agnostic of the choice being taken. That software takes the user from the cloud to the shop floor in just a few clicks. Once the equipment is deployed, it's the actual same user interface that can be retrieved to operate the machine on the floor. For us, at the heart of such simplified industrial automation infrastructure is something that we call machine motion. Machine motion is a cabinet-free way to deploy industrial equipment. It's a motion controller that includes drive, safety system, power supply, and that can connect in a really plug-and-play fashion with a variety of actuator, whether it's roller conveyor, belt conveyor, electric cylinders, pneumatic cylinders, rotary actuators, enclosed rack and pinion ball screws. But all of those devices become agnostic of and plug and play with the controller. And again, it enables anybody that can connect a wire basically to then deploy linear actuators in a very easy and straightforward fashion. I like to say that this is the equivalent of plugging a mouse and a keyboard to a desktop computer, but now applied to industrial automation. But again, keeping that single wire philosophy. And I'll touch just on a few remaining items before we open it up with question. But with the modularization of the hardware component, also come the modularization of the apps that can be used. And here we show two examples of what we call machine apps, one for palletizing, one for path following. But in both cases, those purpose-built apps are off-the-shelf available with customizable user interface, entirely hardware agnostic. So if the palletizer is a 2-pallet or 3-pallet palletizer with separator, no separators, 1 in-feed conveyor, 2 in-feed conveyor, it's the same software that can be used to make the palletizer work, configure each pallet pattern in just a few minutes, basically. And the same logic goes for any path following application whether it's a glue deposition, routing, pattern drilling, again, pre-built app that prevent users to create purpose-built or custom-built code specific to their equipment. One thing that becomes obvious, and this is a trend that we will see with several vendors in the industry, is this applicationalization of the use cases. And we see more and more use cases being productized, which again make the act of then deploying them much easier. This is just a few that Vention support, but there's this trend is there to stay because it simplifies quite a bit the barriers to adoption of industrial automation. Now, I've talked before about partners that are coming together to serve that new market of more democratized industrial automation. And for us, it was quite obvious that we needed to make space for them to participate. So in the Vention platform today, you have the choice to work with folks like Universal Robots, Doosan, ATS, SMC, Dorner Conveyor, and a lot of other players that want to make sure they can tap into that more do-it-yourself, that more self-serve expanding market for industrial automation. And this is one of the purpose of MAP, is to make sure that those can participate. And obviously some of the components, this Legofication of the components available within MAP. There's hundreds of more we could have shown on this page, but the intent here is to create standardized components that can be compatible with one another, that are fully embedded into the design software as well. And last, I'll touch on the last piece of technology, but it's my team, again, that portal, that web-based portal that every team can access to follow their project and deploy them. That's what I had for today to talk about MAP, and I'll be happy to give the microphone back to Mike for some question. But I hope it helped you understand a little bit how the market for industrial automation is expanding to serve a new class of user that are seeking a more democratized experience.
Great, thank you, Etienne. There's a lot going on there. Even beyond the democratization, there are a number of trends or ideas, I think, underlying that that have far-reaching implications for the machine design community or the automation industry. A couple of things that really jump out to me is the idea of taking this, abstracting out or removing a lot of the complexity from what has traditionally been. Just when you were saying in your opening remarks about having to source 10 different products, or spend a lot of times just picking out one actuator just to make sure that it fits with all the other components, and just being able to, like you say, the Legofication of the components, so that one just plugs one thing into another and so on and so forth, and they can think more at the subsystem level rather than at the individual widget. Which one is going to go, which one are we going to buy, how's it going to connect to everything else. And the other thing that jumps out at me is that idea that beyond like the Onshape just for machine design, if that makes sense, and stuff, that Onshape web brace, but then specifically targeted at, is the idea that, as you said, the hardware agnostic. It's not so much being tied to a Rockwell or a Siemens or a fill in the blank. It's what do we need it to do? Which hardware is going to make it happen, no matter who it comes from, and not worrying about how one thing is going to talk to another. Anyway, what do you think? What kind of implications does this have for giving more agency or more involvement to the customer to be able to design their own automation system? How does that change things down the road? I mean, obviously there are some systems that are going to be perfect for Vention. There are going to be some systems that might be a little more sophisticated, or maybe have to be built in different parts and then connected later. But what do you think that this means going down the road as Vention becomes more and more sophisticated? Sorry.
This is a great question. There's a portion of the world that will change and a portion that will not. And you know, Vention is good for a certain amount of use cases, and the traditional approach is better suited for other type of use cases as well. And it's very important not to mix the two of them. You know, for a manufacturer that is seeking high throughput system, I think you can afford to invest that more engineering intensive design cycle, you know, to have the right size solution for that high throughput process. And this will not be going away. You know, it will remain, right? But there's a huge market expanding right now with factories that have never done industrial automation are putting their first robot, their first automated equipment, their first palletizer, their first conveying line. And their volume is such that they are at the margin between, should I automate, should I stay manual? My local authority, you know, give me incentive for me to automate, but I'm not sure if and suddenly, you know, a platform like Vention or MAP changed the game a little bit for them, because you reduce the cost of automating by so much that they can do it by themselves in a, you know, one step at a time, right? They can put the first robots in, generate payback on that, then move to their next project, then move to the next project. And their alternative would have been nothing in the current world, right? They would not have been able to afford the alternative with their current throughput. So to me, that's where Vention is really right size. Like that's where the sweet spot where a platform like Vention can create tremendous value, and is to help those manufacturers to now have access to those technology. Now, the reality is, even in a large high throughput plan, you still have low throughput process. And I'll give an example to that. In a car manufacturing assembly line, the line is high throughput, but the metrology department is low throughput. They don't inspect every single car in the metrology department. Just a few get pulled out of the line and body panel are inspected. So that process is still low throughput, right? And then, you know, obviously you can serve them pretty well with a platform like Vention. So it's about having the right use cases for the right tool, whether the right process, whether more traditional or more map based. But one thing for certain, there's now a new option that didn't exist before.
Great. Well, let me jump into some of the questions that we've got here. Let's see. Does this process still suit emerging markets where human labor costs are much lower?
So I can speak from an empirical evidence for us. You know, Vention has been active on all 5 continents. So that means we find use cases where a platform like this can create values in all cases. Now, what we tend to see adoption are folks that are under shorter life cycle product, and where again they value time of deploying equipment in a very different way, because if they can extend their product life cycle by just a few months by putting in place their manufacturing system faster, then the economic for them is not one of deployment costs, is one of product life cycle behavior. And that has been true on all 5 continents.
Great. And next one, in such emerging markets, is the 20,000 unit break even now more even higher, say 100,000 units? Was that a number that you referred to, the 20,000?
Yeah, exactly. I think the logic highlighted in the question is right. 20,000 for us was a kind of a center of gravity, but there's a whole distribution around that 20,000 units. There might be processes that are obviously in a lower cost environment market would be much higher. Simon, I think at ATS highlighted it well. It's also highly dependent on other parameters, such the value of adding throughput or not to the line, the value of cost of quality as well in that line. So there's a lot of other parameters, but if you just isolate for labor costs, yes, there's a spectrum that we see. 20,000 for us has been the center of gravity, but we see quite of a spectrum here.
Where do you? I know you guys have been adding products, you know, that you've certified to interact with each other at a rapid pace. Where do you see? Do you have projections as to how fast that product catalog will how fast it'll grow or where you want to see it get to eventually?
I think the beauty of map is that the map provider can have a direct connection with the end user. So
Hmm.
for us, that roadmap in that direction come a lot from those interaction. We have a chance to understand a little bit what every sector's industry are seeking, and we leverage their input quite a bit to guide the direction. Um, Today we have a chance to work with some car manufacturers, some building material manufacturers, electronic provider, robotic companies, and their input is actually quite valuable to make sure we can serve their use cases as well, and we leverage that to guide the direction of the platform.
Great, great. Can you explain more about how the control panels can be standardized and still comply with CSA and other government standards for electrical installations?
Yeah, that's a very good question. So, machine motion, for example, is certified as per CSA, as the question pointed out. For us, the thesis behind this, or the inside of the machine motion controller, is always the same. It's a fixed system that includes, again, safety system, a power supply, drives, control cards. It's based on the Linux technology, which is a lot of the new, more recent control technology are emerging on right now. The box itself is a certified a product as it should be, and it's a plug and play solution. Now we do have clients that will be seeking obviously a full safety assessment, and that's where integrators that have that expertise become quite handy, because based on how they've assembled the entire automated equipment, system certification may also be required and safety assessment will be needed. So that doesn't change, and that's part of the process that will not change, and some will, but when it comes to safety, it doesn't.
Mm-hmm. Great, great. How do you take care of warranty in such a, I guess they're saying, given the mix and match kind of scenario that your product category allows, how do you take care of warranty issues?
It's a great question, and for some of you that has been working with Vention, there's a couple of things that we do to make sure that client designs are well done. One of them is, at the end of the day, client buy a list of parts, but it's a bill of material that they purchase based on the design they've done. But we do provide assistance throughout the map if client are seeking assistance. There's a little feature called Request a Design Review, where a client can connect with an application engineers here as part of our team to make sure their design will respect law of physics, that component will be well used, that nothing will be missing, and that makes sure that the everything has been followed properly. We publish a tremendous amount of user documentation that is very digested, very accessible, to make sure people know how to maintain their machine, the various components that can be made out of it, and so on. All the Vention components obviously come with a 1-year warranty on every single component, but they have to be used within their limit that are publicized, very openly on the website, alongside all of our architectural standard that is also fully public on the website.
Mm-hmm. There's a very related question here. I think it's how do you navigate safety and reliability? Is it recommended or simply implied? I think you were saying how if it gets to that point where that becomes a larger issue, I guess maybe liability is involved in there too. There is a certain amount of working with a traditional sort of OEM, maybe there's kind of a sign off or we've set this up and we certify that it's good to go. I wonder how does that play into the Vention business model?
No, that's a very good question, and we have a chance to work with a network of system integrator. I think that have a very close tie with Vention, and a lot of them have the ability to provide safety assessment. And when clients design equipment that command such a thing, they can tap into that services, make sure they get the full safety assessment done on their design. So yes, it is available.
Mm-hmm. It could also be a great tool for other kinds of custom machine builders. It doesn't necessarily have to be at the manufacturing or at the user level. I'm sure if 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 a design, a machine designer needed something quick or needed some kind of subsystem that they could throw to, that would integrate later into a larger system, they could also avail themselves of Vention as well. I imagine you run into that.
Absolutely, yeah. We have a chance to work with a numerous amount of system integrators that, for them, if they can save a little bit of design time for a certain aspect of their project, it means it's more profitable business for them, and obviously a better health on some projects. So we had a chance to work with a fairly large community of system integrator that use Vention as one of their tool in their back pocket for the right project.
Great, great. Okay, well, we've run a little bit over time, but we will head into our second break now. Thank you very much, Etienne. I appreciate you doing this, and I think everyone found that very informative.